Okay, so based off what we've been talking about is we've been talking about quadrilaterals, right? And so a quadrilateral is just that four-sided polygon. And then within the quadrilateral family, we've got a bunch of other polygons that have special rules, okay? So that's what we've been doing. We're not going to make a foldable, so I'm going to skip the foldable part because we've got a tree diagram instead. Okay, so last class, let's just review real quick. We did parallelograms. Okay, a parallelogram is a quadrilateral. So, right, but a quadrilateral is not necessarily a parallelogram. So you have to start thinking that way. A quadrilateral is a parallelogram if and only if it has two sets of parallel sides. So that's what makes it. And you guys should have that written down already. And what's nice is parallel is in the word, right? So the properties we went over yesterday are that both pairs of opposite sides are parallel. Both pairs of opposite sides are congruent. Both pairs of opposite angles are congruent. Consecutive angles, or we call them adjacent angles, are supplementary, which means they add up to 180. And then we learn that the diagonals bisect each other. So one diagonal cuts the other one in half and vice versa. Okay? So that's what we went through already. Not doing the full book. Okay. So now we're on to rectangles. So a rectangle is a parallelogram. So it's going to follow all the rules that we went over with a parallelogram. Okay, and so I think that's already filled in for you on number 1. It says all the properties of a parallelogram. In addition to that, it's going to have 4 right angles. Okay, so for number 2, you can either write all angles are right angles, 4 right angles, however you want to write it. And right angles mean what? 90 degrees. Good. So are opposite angles still equal? Like a parallelogram? Yeah. And then are consecutive angles or adjacent angles, do they still add up to 180? Yes. The difference is they are now all 90. So instead of maybe a slanted quadrilateral, it's now nice and straight with 90 degrees. Okay. So in order for a quadrilateral to be a rectangle, it can only do that if and only if it has 4 right angles. So that's the definition of how it becomes a rectangle versus just a parallelogram. Okay? Or versus just a quadrilateral. What's interesting about the diagonals for a triangle is they are congruent. Okay, so now the entire diagonal, so let's say like this diagonal was 20, the other diagonal would also be 20. So the diagonals themselves are congruent to each other. So that's number 3 on your tree diagram. Diagonals are congruent. They still cut each other in half because they're still following parallelograms. So not only are they equal to each other, their halves are all going to be equal, right? Because if we're cutting this, I said this was 20. If it's cutting it in half, this is 10, this is 10, this is 10, this is 10. So now all those are equal, okay? So number 4 is optional right now. I don't like the wording it has on my tree diagram. I would just write something like, and you don't have to, but knowing that the diagonals each half is going to equal each other. Okay. That wasn't on the original tree diagram, but I don't like the number 4 it gives us. It just talks about right angles again, and I don't see a point of repeating it. So you can either leave 4 blank, or you can write that each half of those diagonals will all equal each other also. Okay. Number 2 was all the angles are right angles. Okay, we're going to move over to a rhombus. Now, a rhombus is not a rectangle. Okay, see how it's not underneath it? So a rhombus does not follow the rectangle rules. But a rhombus is a parallelogram. So that's why you'll see the little connection where it goes up to the parallelogram. So the first one says that all the properties of a parallelogram. Okay. Now, the difference between the rhombus and the parallelogram is in a rhombus, all 4 sides are congruent. So that's going to be number 2. All sides are congruent. You can either write all 4 sides or just know that all sides are congruent. You'll notice we do not have right angles in a rhombus, okay? So that's why it still follows. Now, opposite angles are still congruent because that follows a parallelogram, but they're not right angles here. Okay, the next piece about a rhombus, so in order for a quadrilateral to be a rhombus, it has to have 4 congruent sides. That's what makes it a rhombus versus just a parallelogram. So this is kind of interesting. So the diagonals bisect a pair of opposite angles, okay? When we're doing just like a rectangle or parallelogram, it doesn't necessarily cut the angle in half, okay? But it does do that in a rhombus. So in a rhombus, diagonals bisect a pair of opposite angles. What? Yes, 3. And I'm actually going to add a number 4 to rhombus. I know. I'm messing up your whole tree. So number 4 kind of goes with number 3, though. So because the diagonals are bisecting the angles, the diagonals are very nice and straight. Because in order to bisect an angle, it's got to be cutting it straight. So what happens is the diagonals are perpendicular to each other. So when they're crossing at that 90 degrees. And so what that means is all 4 of these middle angles right here are 90 degrees. These 4 middle angles where they intersect. So that's why I said it kind of goes with number 3, but I like to have it separate because it has its own purpose also. So what's interesting about this is when we start solving different angles for a rhombus, you now know that these 4 angles are 90. It also creates these triangles, right? But you know that like this small angle is going to equal this small angle, right? And then you also know that the big opposite angles are equal to each other. So sometimes you can actually use triangle rules to find some missing angles also, okay? So a lot of times we'll use some of those triangle rules that we learned in the other units to help us. Interesting fact about rhombus. Plural can be rhombi or rhombuses. Both are correct. Isn't that weird? If you look it up to say like what's plural for rhombus, they're actually both right. Just a random thing that one class we looked up one time. All right, the last one we're doing today is a square. So a square is a parallelogram. It's got 4 right angles, so it's also a rectangle. It also has 4 congruent sides, so it's also a rhombus. Okay? And so you'll notice under square, there's nothing really filled out for you to put there because all of its properties come from a rhombus, a rectangle, and a parallelogram. Okay? So a rhombus has the 4 equal sides, so does the square, but it also has the 90 degrees like a rectangle. So if we wanted to look at this as a family tree, the rhombus and the rectangle are the parents and the square is the child because it has pieces of both. That's how I always remembered it. Okay. So in order for a quadrilateral to be a square, it has to have 4 congruent sides and 4 right angles. But then it will still have all the other properties. So it will still have the diagonals that are perpendicular. It'll still bisect the opposite angles. It will still have diagonals that are congruent. And it still has like the opposite sides are parallel and stuff too. Okay. So since a square holds the properties of a rhombus and a rectangle, you can say that the quadrilateral is a square if and only if it's a rhombus and a rectangle at the same time. Right? Okay, so what's interesting is if we put this as a Venn diagram, it kind of shows a lot. So the circles or ovals that are inside each other mean it follows those properties, right? So we have quadrilaterals is our big picture. That's our blue rectangle, right? And then inside quadrilaterals are all these little families. And so you'll notice the parallelograms is a more generic, right? So very, very generic is quadrilateral. Then we go a little more specific is parallelograms. And then we go into the 2 ovals of rhombuses. We have rhombuses here. Rhombuses and rectangles. Those are both parallelograms, right? But they're not on each other. So a rectangle is not a rhombus and a rhombus is not a rectangle. But if they're both, then they're a square. Okay? And so the Venn diagram is kind of interesting because it'll show you what can be what. And so like back in middle school, I'm sure you've heard the saying that a square is a rectangle, but a rectangle is not necessarily a square, right? And so that's where this comes from, where my square is a rectangle, it's a rhombus, it's a parallelogram, and it's a quadrilateral. It's all of them. Okay? And so if we add the properties into the Venn diagram, it gets a little crazy. And so the rhombus would follow its properties that are inside, but it would also follow the properties for the parallelogram and the quadrilateral, right? So the square has all these properties together. So the square is very special. I'm going to stop recording for the notes.